sum of exam score divided by number of exams. So let's say we have, normally we have a minimum of 5 exams. So the average, so the passing rate will be 50. So in the exam, nagbibigay ako ng bonus points, 20% bonus points. So walang masiro sa exam except for may mga violation. Like for example, for example, cheating, or may mga case minsan na sa students, iba yung gumawa ng exam. Okay? So in that case, automatic na yun na incomplete, or meron pa rin siyang way to pass the dun sa final exam. Okay, so the final exam, so the last quiz will be considered as the removed exam. So for example, for the all exams, your average is below 50, then your final exam will determine if you will incomplete or pass the subject. Okay. Then for the composition of exam or quiz, so normally 2 items per topic. So after discussing the topic, the following meeting will be the quiz or exam. So the exam will be 1 hour and 30 minutes, so 45 minutes each item. Then for final examination or removal exam, 2 items. One will be the last topic. So whatever is the last topic, normally the development length and okay. And then 1 item for the previous topic. So dito meron kayong chance to pass the subject kasi yung any previous topic is similar siya kung ano yung previous exam. Then palis yung cheating since online, so mahirap naman yung cheating. So I think nasa inyo lang yun kung mag-cheat kayo or any other form na dapat maganda pa rin na sa sarili nyo kayo yung one exam. Okay? Except siguro yung obvious na cheating, yung iba yung gumawa o iba yung pinasang answer sheet, consider as cheating. So on the quiz answer sheet, so ang ginagawa ko lang is yung quiz natin is written pa rin siya, hindi siya multiple choice. So what you need to do is to do the solution on any clean paper, okay, A4 size or any other clean paper or answer sheet. And then ang gagawin niyo is bigyan kayo ng time, yung time ko kayo submit siya, then picturean niyo lang siya, then submit niyo siya sa Google Drive. Okay? And then during the exam, there are cases na may iwasan hindi kayo available or may mga trabaho kayo. So just inform me, okay, in advance, okay? Pag valid naman yung reason, pwede ko kayo bigyan ng special quiz or exam, or sometimes pwede natin i-disregard yung quiz na yon sa part na yon. But kailangan lang yon, hindi naman lagi. Okay? Then during the exam, kailangan open yung camera. So everything is open notes and books. So marami kayong resources sa internet na pwede nyong pagkunan. Okay? So any question or any clarification on the class policy? Okay, so walang clarification. Okay, so let's go to the topics to be discussed the entire semester. So in the reinforced concrete design, we have two methods of design, the working stress design or WSD and the ultimate strength design. So yung ultimate strength design is yun yung ginagamit na ngayon sa design. Except for some special structures, WSD pa rin or working stress pa rin yung ginagamit na design. So ito yung naunang design kasi na ginamit sa reinforced concrete. And the later part, naging ultimate strength na siya. Okay? So before, ang discussion ng working stress design and ultimate design is parehas yung kung ano yung mga structure, ano yung mga members ng structure design di-discuss. Pero ngayon, we just limit the discussion for working stress design for beams. So we are not going to discuss anymore the design of column, slab, footing, or working stress design. Okay? So for working stress design, the topics are single reinforced rectangular beam, okay, double reinforced rectangular beam, and regular sections. Then for ultimate strength design, single reinforced rectangular beam design, or just simply single reinforced beam, 3 beams, double reinforced beam, design for shear, one-way slab, two-way slab, column, footing, but footing will be optional. I think sa BSR iba meron kayong foundation design. Foundation design ka sa BSRA?
Wala pang specific subject, sir, pero natakol po sa ibang subjects.
Ang subject?
Meron po, sir, sa structural, tsaka meron konti po sa quantity surveying po.
Okay. So ano yun, parang overview lang. Okay. So dito, gagawin natin, i-discuss rin sa inyo yung design ng footing kasi para kompleto yung reinforced concrete design. Okay. Then the last topic will be the development length and deflection. So all in all, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 3, so we have 12 topics. So 12 topics. So pwedeng pag mahaba pa yung time natin, ginagawa ko bawat isang topic, one exam. Pero may mga cases na kung mga kulang na sa time, pinagsasabay ko na lang yung exam, kunyari na about sa working stress design, gagawin ko tong one quiz na lang. Okay? Then for the other, 2 topics per quiz. So basta at least minimum 5 quizzes tayo plus 1 final exam. Okay. So to start with the reinforced concrete design, so I'm just going to tackle the historical background of the reinforced concrete design basis, advantages and disadvantages, and the mechanical properties. Okay. So concrete and reinforced concrete. Okay. So concrete is a mixture of sand, gravel, and crushed rock or other aggregates held together. So unlike with other construction materials, hindi siya homogeneous like steel. Okay. So yung composition niya is 3 major components. Sand, gravel, okay, and of course the cement. And sometimes there are cases na for special construction, okay, we need to add or include admixture, okay. So these admixtures will depend on the requirement of the construction site. For example, for road construction. So kailangan mabilis yung mabilis yung curing niya. So maglalagay tayo ng admixture para mapabilis natin yung curing. Then for a massive structure like dams, okay? So naglalagay naman tayo ng retarder para medyo bumagal yung curing niya. Kasi pag sa dam, pag masyadong mabilis yung setting niya, magkakaroon ng fault joint. So hindi kakapit yung mga halo. Okay?
Sir, magandang gabi po.
Yes.
Hindi po ata na nagna-next po yung slide po. Thank you po.
Ganun? Ito.
Hindi pa rin po, sir.
Okay. Lalit. Tignan ko lang ha. Bakit? Yan, nagbabago na.
Yes po, sir.
Okay. So, just to give you on the brief historical background of reinforced concrete, so yung mga gumamit ng reinforced concrete are the Romans. So, they are the one who first made the cement. So, before, they called it as pozzolana. Okay. Then, in 1796, okay, the cement was discovered in England, and this was sold as, we call this as Roman cement. So and then in 1824, okay, so in 1824, doon lang nagkaroon ng start of using what we call the Portland cement. Okay. Then in 1850, so yung unang usage nung concrete, so dati wala pa siyang reinforcement. So just purely concrete lang. Meron mo silang reinforcement but not the typical reinforcement na ginagamit natin ngayon. Okay? So yung unang reinforced concrete, ginamit siya in boat construction. Okay? So dito sa boat construction, they just use ordinary reinforcement using wires or bars. So dati kasi yung mga unang panahon, kung makakaano kayo ng mga old buildings, makita niyo na yung mga reinforcement dati, hindi pa siya deformed bars, so wala pa siyang corrugation, just ordinary plain bars. And in some cases sa mga provinces, makikita niyo pag nag-demolish kayo ng mga old houses, yung ginagamit nila, like for example in the north, marami gumagamit ng mga bamboo for the reinforcement instead of reinforcing bars. So from the start of the reinforced concrete until 1861, okay, or until 1850, wala pang ginagamit na design code. So yung design dati is just designed by feeling. For example, gagawa sila ng isang structure, okay? Then hula lang nila kung ano yung dimension. Pag kunyari, parang small bridge kunyari, kung bumagsak yung bridge, lalakihan lang yung size. Kung okay yung bridge, okay, so assist pa rin. Wala silang binabago. Until 1861, okay, doon lang karoon ng development ng mga design codes or basic method design. Ito hindi pa siya code, okay? Just a basic method for the design. So dito nag-start yung publication ng mga references regarding reinforced concrete. Okay? And then in 1867, so doon nagkaroon ng patent for the reinforced concrete. So ginamit na siya sa mga basin, reservoir, road, slab, arcs, footbridges, and other structure in France and Germany. So makita nyo dito, yung mga German yung halos nag-start ng reinforced concrete. Then in 1868, okay, so in 1868, ito introduce yung Portland cement. Yes. Merong nakapasok. Okay. So in 1868, so Portland cement was introduced in the United States. Then in 1870 is the year where the first Portland cement was manufactured in United States. So yung Portland cement, so kaya tinawag na Portland cement, kaya kasi yung yung tsura ng semento na galing sa Portland, USA. So lugar yon kaya tinawag lang Portland cement. And then in 1875, so doon pa nagkaroon ng first reinforced concrete building in United States sa New York. Okay? Then in 1877, although dito may mga references na ginamit, pero in 1877 lang, doon lang nag-start ng i-analyze o magkaroon ng thorough study regarding the stresses of reinforced concrete beam. Okay? Then in 1884, okay, dito nag-start yung usage ng deform bars. So ito hindi pa siya yung kayang deform bars nakita ninyo, kundi parang tinis lang siya. Tinis lang siya na parang cut bar siya, tapos tinis para magkaroon ng corrugation. Okay. Then in 1890, so makita ninyo almost one century lang yung reinforced concrete. So din nag-start itong development or usage ng reinforced concrete throughout the world. Kasi dati, mostly either steel, metal, or timber yung ginagamit sa construction. But now yung timber natin, yung mga wood, bihira nang magamit sa Pilipinas. But in the United States and especially in Hawaii, ginagamit pa nila yung mga bahay nila made of timber or wood. Okay, so this is the components of the concrete. So water, aggregate, so ito yung ingredients. So rock, either crush siya or yung mga rock coming from or galing sa mga river. Okay. Then, ito yung admixture. Okay. So yung admixture, napakalit na component lang siya. So, liquid components siya na inihalo sa semento. Okay. So kaya tayo nagkaroon ng reinforced concrete is that yung concrete is very weak in tension. Although meron siyang tension capacity, normally the tensile capacity of concrete is very small. Kaya with that, so ginamitan siya ng reinforcement so that the tensile load will be carried by the reinforcing bars or steel rod. So for a simply supported beam, okay, the upper part of the beam is in compression and the lower part or the bottom part of the beam is in tension. That's why the compression side will be taken care by the concrete. Then the tension side will be carried by the reinforcement. Okay. So in design of reinforced concrete, there are a lot of parameters which is unknown. Okay. So maraming variable, yung width, yung depth, yung area of reinforcement. Then the other force for yung strain, concrete is the strain and stresses, secondary na lang to. But in design, so lahat ng tatlong variables are unknown. So that's why in the design, nagkakaroon kadalasan ng trial and error. Lalo na, of course, magales yung structure ninyo. Yung pagkukuha kayo ng mga moment, simple structure sa simple frame, para makuha mo yung moment distribution, kaya mo ng dimension ng members. So, since wala ka pang design, manghula ka lang ng dimension. So, normally, ang ginagawa natin, initial stage is we assume the sizes of the beam, okay? And then, determine the moment. So, from that moment, again, solve for the required B and D o yung dimension ng beam natin, yung width saka depth. So of course, yung width and depth natin, variable pa rin siya. So ginagamit natin kadalasan, pinipix natin yung width. Okay? Or sometimes, magbibigay tayo ng ratio ng B and D. So normally for optimal design, yung width to depth ratio niya, yung depth niya is nag-range from 1.5 to 2.5 of width. So yun yung optimal design o size na assumption sa pin. Okay? Tapos from initial analysis, so makakuha tayo ng width and depth, then i-check natin ngayon siya kung tumatama siya or nagpaparehas siya sa inassume natin. So pag di siya nagpaparehas, mag-run ulit tayo ng analysis. Okay? So after running analysis, check natin ulit kung tama ulit na sum natin hanggang sa dumating yung point sa design na yung in-assume mong width and depth is equal to the design width and depth. Then of course, another factor is the area of reinforcement. So like for building with requirements architectural, pwede mong damihan yung reinforcement mo para mabawasan naman yung sizes mo nung beam. Kaya lang, of course, mas mahal yung steel reinforcement kaysa dun sa concrete. Okay? So this is just the summary of the design, how to design the reinforced concrete. So a trial and adjustment procedure. Okay? So the cement, okay, composed of the following. So the limestone, silica, and aluminum. So normally the specific gravity ranges from 3.12 to 3.16. So depending on kung ano yung ginamit na raw material. Kasi pag mas maraming silica siya, okay, mas mabigat yung simento natin. Then the weight, the standard weight of the one bag of cement is 94 pounds or equivalent to makita niyo sa mga bags, nakalagay sa bags is 40 kg yung commercial size niya. Okay, so these are the types of Portland cement. So we have normal type 1. Type 2 is the modified one. Okay, so yung normal type and modified is the all-purpose. Okay, all-purpose na for building construction and structures. Then the type 3 is the high strength. So normally, this will be cured in 3 days. So in 3 days time, nakuha niya yung required compressive strength ng semento. Then the type 4 is the low heat or used in mass concrete, like for example, dams or the foundation of the bridges. Diba, yung mga foundation ng mga bridges natin, malalaki siya, more than may mga foundation ng bridges na ang size niya is 4 meter in diameter. Okay? So, ginagamit siya ng type 4. Then, the other one is type 5 or the sulfate resisting. So, ito yung mga site na exposed sa mga sewer structure o may mga acid or yung mga, halimbawa, yung mga malapit sa dagat, ginagamitan ng type 5. So, sa lahat ng simentong yan, ang difference niya lang is yung component niya. So, magkakaiba lang yung composition niya ng lime, silica, and aluminum. Okay, so for the water, so water is used. Okay, so generally, drinking water can be used in mixing. Okay, so but in some cases, for example, gumagawa ko ng mga structure near the ocean or sea, so may mga contamination siya. But generally, dapat yung gamitin yung tubig is free from other chemicals. So basta drinking water siya, pwede siyang gamitin. But in some cases, like for example in rural areas wherein the the water is not available, lalo ginagamit minsan yung mga malapit sa ilog, okay? So ginagamit na rin 'yon. Kaya lang ang nagiging problem nun is yung strength niya, mas marami required na cement pag hindi clean water yung ginamit. Okay? So one factor na nagbibigay ng strength ng concrete is the water cement ratio. Of course, the smaller amount of water will give the higher strength. But the problem is, pag maliit naman yung water, konting amount ng water mo, hindi siya workable, napakahirap haluin. Mabilis yung mag-cure. Okay? So mahirap 'yon pag in case na nagbubuhos ka ng malaking structure, baka hindi na magdikit yung yung mga exploring mo sa structure. So doon ginagamitan yung yung mga admixture. So ito yung coarse aggregate, fine aggregate. So normally the coarse aggregate yan yung mga natural stone, natural gravel, or yung mga aggregate na crust. So yung fine aggregates naman, yan yung mga sand. Okay? So you will recall in your materials. Okay? So fine aggregates. Okay? So ito yung mga passing sa number 4 to number 100. Ito yung typical grading, okay, nung aggregates. So yung aggregates natin, hindi lang basta buhangin yung ginagamit natin. So of course, sa mga small construction mga maliit na bahay lang, hindi masyadong binibigyan pansin to. Basta may meron ng sand, okay na sa kanila yun. Pero sa mga bigger construction o yung mga high-rise building or mga infrastructure projects, so kailangan ma-satisfy yung grading requirement ng mga materials o ng aggregates. Okay? So ito yung admixtures. Okay? So admixtures are materials other than water, aggregate, or hydraulic cement. So this admixture is used so that the concrete will so the purpose is to modify the properties of concrete. So this is to make the concrete suitable every other work. So depende sa requirement ng project. So yung ginagamit na admixtures. So these are the typical types of admixture. Accelerating admixture. So to accelerate the curing. Air entraining admixtures. Ito naman yung mga para yung mga air bubbles. Then water using admixture. Okay? So ito yung mga kailangan mo ng high strength concrete. So para makamit mo yung high strength concrete, babawasan mo yung water. So but pag nagbawa ng water, may matigas yung halo mo. So maglagay tayo ng admixture na water reducing. So ito may others, yung fine divided minerals, admixture for noise lamp. okay, for polymers, then so on. Marami pa itong admixtures na ginagamit na to. Marami commercial admixtures ngayon na available sa market. So this is the typical manufacturing of cement. Okay. So we have two common cement ginagamit natin sa Pilipinas. So we have the OPC and PPC. So OPC stands for Ordinary Portland Cement. Okay. And then PPC is the Pozzolanic Portland Cement. Okay. So yung difference ng dalawa is depending on the usage. Okay. For the ordinary Portland cement, so dito sa ordinary Portland cement, mas mahal yung pag-manufacture sa kanya. Kasi ginagamit ito ng mga special materials. Okay. Then for pozzolana o PPC, so this is cheaper materials. Okay. Then yung components niya mag-iba. Okay. Then mas mo yung pozzolan. Then the fourth difference is mas high density yung OPC compared to PPC. Then in terms of strength, mas high strength yung ordinary Portland cement at early stage. Okay? So PPC o Pozzolana Portland cement, initially mababa yung strength niya. So later papakita ko sa inyo kung ano yung detailed comparison in terms of strength. So for Portland cement, setting time is faster than PPC. Then ito yung number 7, yung mas costly. OPC and PPC. So ito yung tinatawag natin na clinker. So dito ito yung ginagamit sa ordinary Portland cement. So mas special yung ginagamit niya mga components. Okay? Unlike sa pozzolan, so just ordinary powder na cement. Okay? So pozzolanic material lang siya, either natural or artificial. But in OPC, ordinary Portland cement, so kailangan mo na mag-produce ng mga clinker, ito, yung mga solid materials, bago siya gawing Portland cement. So ito yung process, how to make the clinker. Okay, so in component nung limestone plus clay, and some pinapainit siya, and then rotate. Okay. Then, nalalabas na yung clinker. Ito yon, yung component ng OPC. Okay. So again, yung OPC and PPC, so ang difference lang is depende dun sa component. But in terms of cost, mas mura yung PPC o Pozzolanic Portland Cement versus OPC. So meron pang another cement, but very seldom used in the Philippines is yung PSC. Okay. So yung PSC, yan yung Portland slag cement. Okay. So ito yung blended cements. Bihira gamitin ito sa construction sa Pilipinas. So kadalasan ginagamit lang ito sa mga kadalasan sa mga special construction. Okay. So ito yung difference ng OPC and PPC. So take note that in this trend, for OPC, in 3 days time, it achieved a strength of 35 Newton per meter squared or 35 megapascal. Whereas in PPC, in 3 days, meron lang siyang 29 megapascal. Then in 7 days, okay, sa OPC, it can attain up to 43.5 megapascal, while in PPC, yung compressive strength lang is up to 39 megapascal. But in 28 days, you will notice mas mataas na yung strength ni PPC versus OPC. So in other words, if you need high strength o yung mga project na kailangan mo ng mag-bis yung construction, go to ordinary Portland cement. But in case hindi mo kailangan ng ganong hindi mo kailangan ng requirement, wala kang requirement sa time, like sa mga residential construction na maliliit lang, okay? So mas practical na gamitin si pozzolan. So kadalasan yung mga pozzolan ginagamit siya sa mga kadalasan sa mga roads. Kaya lang yung supply sa atin ng pozzolan is napakaliit. Kaya kadalasan hindi siya available sa market. Although naibebenta siya, order ka, medyo matagal yung delivery. Kaya either road or mga high-rise structure, ang ginagamit na is ordinary Portland cement. But in terms of durability, for plastering, mas better si pozzolan. Okay? Sa pozzolan kasi mas minimize yung cracking compared si Portland cement. Then for workability, yung difference niya. Then setting time, okay. Then yung fineness. But mali ngayon although magaspang si Portland cement, since meron tayo ngayon ginagamit na mga special na mga plastering, okay. So hindi na problema yung smoothness ng surface ng concrete. Okay, and then in terms of resistance against chemical, okay, mas magandang gamitin si pozzolan. Okay, kasi ito naka-design siya to resist the attack of sulfate and other chemicals. Although sa ordinary Portland cement, pwede mo siyang gamitin, okay, kaya lang i-modify mo siya, maglalagay ka na ng additives para pwede siya sa mga sulfate attack and other chemicals attack. Okay, in terms of durability, mas matibay si pozzolan, but in terms of curing, mas mabilis ma-cure si OPC or ordinary Portland cement. So in terms of environmental impact, okay, mas environmental friendly yung PPC. Kasi doon sa OPC, gagamit ka pa ng heat sa malaking amount ng carbon dioxide yung may emit using the ordinary Portland cement manufacturing. So ito yung typical uses niya. Okay? So OPC is most commonly used cement in construction. So higher grade, like 53 is not recommended for plastering. So pag ginamit mo yung Portland cement, doon nagkakaroon ng cracks. So very prone sa cracking. Kaya dapat pag gagamit kayo ng plastering, so gamit kayo ng pozzolan cement o PPC. Okay? So OPC can be used for structural members like slab, column, beam. So ito yung major component ng structure natin. So ideal application for ordinary Portland cement is commercial and industrial complexes, high-rise buildings, roads, bridges, flyover, and heavy defense structure. So kung kailangan mo ng mga bomb shell o bomb proof na mga structure, okay, so dapat OPC ang gamitin mo. So PPC can be used in all types of constructions like RCC work in residential commercial. So ito yung mga small residential buildings, marine works with mass concrete like dam, builds foundation for roads, runway, bridges, flyover, etc. So, in terms of durability, go to PPC. Okay? So that's why dito, especially PPC is used in plastering, masonry, tiling, and waterproofing work. Okay? Where strength is not required. So yung mga strength na hindi mo kailangan, so go to PPC. Hawa yung mga halo sa para sa mga CSB. So yung CSB naman di natin sasama sa strength analysis ng building. So pwedeng ano siya, PPC na ang gamitin. Okay, so both PVC and OPC are commonly used in many construction. So depende lang sa designer or the construction manager kung available yung PPC. So for plastering, use PPC. But if the supply is the problem, of course, hindi ka pwede maghintay sa delivery. So madidelay mo yung construction mo. Kaya yung iba, Portland cement na lang ang ginagamit. Okay. Then another component of reinforced concrete is the rebar. Okay. So the following are the reasons why steel is used as reinforcing bars. So number one, during setting, cement concrete shrinks and grips. So pag nagkakaroon ng shrinkage, so the rebar will grip perfectly. So this effect develop a perfect bond between concrete and steel and enables concrete to transfer its stresses to the reinforcing bars after it cracks. Okay. Second, the coefficient of linear expansion of steel is almost the same as concrete. So this helps to prevent setting up internal stresses within reinforced concrete members due to increase or decrease of temperature. So pag may change in temperature, so yung coefficient of linear expansion niya is almost similar. So sila nagkokontrahan. Okay. Then the tensile strength of steel is very high. Fourth, coating of cement concrete around the steel bar protects the steel from corrosion at atmospheric effect. So give and take sa kanila. So the steel will take care of the lack of tensile strength of concrete, and then the concrete will take care for the protection of the reinforcing bars. Okay. Then the steel is cheaper and is the available material. Okay. So these are the types of reinforcing bars. Ito yung mild steel bars. Okay. So makikita ninyo, hindi siya corrugated. So just ordinary plain bar, plain round bar. So and then the second bars or the second types of rebar is the deformed steel bars. So there are several deformed steel bars. Okay, so number one is the PMP bars. Okay, so ito yung nakita ninyo yung ginagamit sa construction. So unit standard o most common na ginagamit sa construction. PMP bars or thermomechanical treatment. Okay. So most economical. So yung PMP bars. So ito yung typical, okay, typical rebar, PMP bars. So meron siyang rib, straight rib, then meron siyang mga corrugation or lag. Okay. So at yung PMP bars, okay, meron siyang core, then meron siyang case. Kaya makita ninyo, pag kinalawang yung bars natin, yung kinalawang na portion na yung case lang yon, pero yung inner core niya, andun pa rin. So protected siya by the case. Kaya pag subukan niyo mag-cut ng rebar, makikita ninyo, merong ibang kulay na nasa loob. So ito yung tinatawag natin na core. So these are the typical characteristics of PMP bars. So high yield strength and ultimate tensile strength. So better ductility and elongation, greater band. Okay, so since meron siyang corrugation, mas makapit siya dun sa concrete. So better weldability. So nowadays, yung mga bars na ginagamit na natin are all weldable. Okay? So ngayon, pinapayagan na yung welding ng reinforcement. Okay? So meron tayong code requirement for the welding of reinforcement. Sa mga kadalasan, sa mga bridge lang ginagawa yung mga welding. Pero sa mga high-rise construction, bibihira pang gumamit ng welding. So, high thermal resistance, corrosion resistance, and earthquake resistance. Then another type of deformed bars is yung cold twisted bar. So meron sa formation, parang twist mo lang siya para magkaroon siya ng deformation o meron siyang na corrugation. So these are some characteristics of the cold twisted bars. Okay, similar to the TMP bars, since meron siyang corrugation, great band strength, so high tensile strength, low carbon strength, content, and welding capability. Better function and less steel consumption. So, mas economical pa rin yung deformed bars compared to other reinforcing bars. So, meron din tayo another form is yung carbon steel bars. So this is the most common type of rebar made up of carbon steel, and sometimes referred to as black bar due to its color. So kung may problema ka sa corrosion problem or yung construction mo malapit ka sa mga corroded environment, like sa malapit sa mga dagat, or yung site mo is dating war zone, so meron sa mga sulfate. So para protect mo yung structure mo, so para may iwasan mo yung kalawang, okay, gagamit ka ng carbon steel bar. And another type is the epoxy coated rebar. So this just similar parang lang siya, parang TMT bars o CTD bars, pero meron na siyang coating ng epoxy. So ang purpose ng coating ng epoxy is to protect this structure lalo na pag exposed to water, where may siyang problem sa corrosion. So sa mga corrosive environment, ginagamit yung epoxy coated rebar. Like for example, sa project namin sa Indonesia, ang requirement nila palagi, since Indonesia kasi parang parang marami siyang island. So halos yung mga structure nila is located within the vicinity of sa dagat. So ang requirement nila as per their government, lahat ng steel na gagamitin is epoxy coated rebar. Then sa stainless bar, of course, kahit nakababad dyan sa water, wala kang required na maintenance. So hindi mo kailangan waterproof yung structure mo. pag stainless rebar na ang gagamitin mo. Okay. Then another type is galvanized rebar. So sa galvanized rebar naman, yun din, ang purpose niya, pag-expose ka sa mga, yes,
Yes po, nawala po yung PowerPoint po. Yung presentation.
sige, stay lang.
Salamat po.
Okay. Napindot ko pala yung stop sharing. Okay. Okay. So another type of reinforcing bars is yung galvanized rebar. So in this rebar, okay, meron siyang protective layer of zinc coating. So may coating lang siya ng mga zinc o ginagalvanize siya para maging corrosion resistant siya. Okay? So again, meron siyang added cost. So mas mahal siya dun sa ordinary reinforcing bars. So these bars is suitable for the exposed to moisture or humid conditions. Then meron ding another type is yung European bars. Okay? Okay, so sa ito nga sa European bars, ito yung mga yung mga rebar na ginagamit sa Europe. Okay? But these are not suitable for weather condition and natural disasters such as earthquake and tornadoes. Okay? Then the last rebar, ito yung pinaka-latest ngayon. Okay? Yung tinatawag natin na GFRP or Glass Fiber Reinforced Polymers. Okay, so these are fiberglass rebar, sometimes also referred to as the fiberglass reinforced polymer rebar. So they are typically made of carbon fiber. So some advantage of the GFRP, so it will never corrode. So kahit exposed ka sa salt or any corrosive environment, wala kang problema sa corrosion. Then, ito mas higher strength, okay, compared to ordinary reinforcing bars. Then another number one, another good characteristic of this rebar, hindi siya conductive ng electrical. So wala siyang problema sa mga electricity. So sometimes minsan 'di ba yung mga may mga problem tayo na nakukuryente sa site dahil yung mga equipment, yung welding o yung mga temporary na mga lighting dumikit sa reinforcing bars. Okay. So another is save material handling and shipping costs due to its lower weight. So mas magang ito compared sa ordinary reinforcing bars. Saves material handling and shipping costs due to its lower weight. So since magang siya, so yung shipping fee mo o pag imported siya, mas mura siya. Kaya lang ang problem nito ay hindi siya basta-basta nabebend kasi mas matigas siya dun sa ordinary reinforcing bars natin. Kaya pag in-order nyo to, dapat naka-bar bending na siya. So kung ano yung pagkaka-bend ng bakal, i-order siyang ganon. Kaya pag nagkamali kayo ng bending o sa fabrication, magkamali kayo ng mga dimension, magiging problema, hindi siya pwedeng gamitin. Sa Pilipinas meron ng nag-introduce nito, I think noong 2012. Kaya lang masyadong mahal compared sa reinforcing bars natin, kaya hindi ginagamit ngayon sa construction. But in other countries like sa Europe, may mga gumagamit ng ganito sa US. Then another type is the welded fabric. So ito yung parang ordinary lang siya, parang wire mesh. Okay? So kadalasan ginagamit to sa mga slab on grade, okay? Or sa mga roadworks. So yung mga welded fabric. Okay. So, yan yung yung materials for the reinforced concrete. Okay. Then let's go to the design basis. So in the design basis, okay, we have the stand design method and alternate design method. Okay. So from early 1900 until early 1960s, so almost all the structures, okay, worldwide is using the working stress design method, or not. Now we call this one as alternate design method, or the allowable stress design method. So dito sa working stress design method, okay, sa lahat ng loads is unfactored. Okay? So yung loading niya unfactored, then ang check lang natin dito is yung allowable stresses niya. So normally for working stress design, the allowable stress is only 50%, okay, of the capacity or strength of the member. Then from 1963, so dito na introduce yung ultimate strength design. So we call this one as the strength design method, or referred to as the USD. So yung ultimate strength design method has rapidly gained popularity because of the following. So number one, it makes the use of more rational approach than WSD. Second, more realistic consideration of safety use. Third, it provides more economical design. So in the ultimate strength design, yung size ng member is smaller compared to working stress design. So in the ultimate strength design, all the loads are factored. Then since factored na yung load, ang kinukuha natin is yung ultimate capacity na nung section. Unlike for the working stress design, ang allowable niya lang is 50% of the strength, but the loads are unfactored. So kung titignan ninyo, halos nagpaparehas lang siya, kaya lang mas realistic yung ultimate strength design. So sa working load o working stress design, unfactored yung load mo, pero 50% lang yung ginagamit mong stress capacity. Sa ultimate design o ultimate strength design, factored yung load mo, normally yung factor niya is 20% to 70% or 40% for live load. But ang ginagamit mo dito is yung ultimate capacity na ng section. So parang halos parehas lang siya. Kaya lang, magkaiba lang yung mga stresses na ginagamit. Okay? So this is the some description of the allowable stress design. So I'll just give you the copy of this one, so for you to read as your reference. So mas matagal na ginamit yung yung allowable stress design compared sa ultimate strength design. Kasi bago lang yung ultimate strength design. Sa United States, nag-start siya 1963, but in the Philippines, nung nag-aral pa kami ng college, 1995, WSD pa rin yung ginagamit natin. Okay? Dati kasi yung subject natin, magkahiwala, isang semester yung working stress design, isang semester yung ultimate strength design. Nung ang ginagamit is yung WSD o working stress design, meron na ring ultimate strength design. Pero ang tawag sa ultimate strength design is alternate design method. Pero nung ginagamit na yung ultimate strength design, yung ASD na lang o yung WSD ang tinawag na alternate design method. So ibig sabihin, you can use you can use the WSD, okay, kahit meron na siyang ultimate strength design. But in totality or in summary, mas reliable ang design sa ultimate strength design or USD. Okay, so papansin nyo dito, in allowable stress design, yung stress ng concrete is linear. Makita nyo, triangular lang siya. But in ultimate strength design or strength design, yung strength ng concrete o yung stress ng concrete is parabolic. Hindi na siya linear. So this one we'll be discussing pag nakarating na tayo sa design ng beam. Okay? So these are some disadvantages of reinforced concrete as structural material. So number one, it has considerable compressive strength, okay, as compared to most other materials. So compared to wood, steel, okay, mas malaki yung compressive strength ng concrete. So it has great resistance to action of fire and water. Okay? So compared to steel, so yung steel, pag nagkaroon ng sunog, pwede siyang mag-melt. Okay? Same with timber. Diba? Pag nagkaroon ng apoy, nagiging ano pa siya, pinapalakas na palalo yung fire. Okay? So reinforced concrete structures are very rigid. Okay? So mas stable siya compared to other wala siyang buckling sa steel and timber. So very critical yung buckling. It is a low maintenance material. So yung konkreto habang tumatagal siya, habang sa long term, mas dumadagdag pa yung strength niya, mas tumitibay yung concrete. Unlike sa timber, nagkakaroon siya ng deterioration, okay? Habang tumatagal, nababawasan yung yung moisture niya, so gumagang siya, nagkakabukbuk siya, or sometimes inaanay. Same true with steel. Okay, pag hindi mo siya binantayan ng maintenance, magkakaroon ng kakalawangin siya hanggang mabawasan yung strength niya o numipis. Okay? Kaya makikita niyo sa mga diba, sa mga structure, pag steel, napakahirap ng maintenance. Okay, number 5, as compared with other materials, it has very long service life. Okay, so under proper conditions, reinforced concrete structure can be used indefinitely without reduction of their load carrying capacity. Okay? So, hindi na babawasan yung strength, okay, ng concrete. Number 6, it is usually the only economical material available for putting basement walls, piers, and similar application. Although yung steel or yung timber, ginagamitan na siya as foundation, nakamat siya, kaya lang mas magastos. Okay. Number 7, special features of concrete is its ability to be cast into an extraordinary variety of shape, from simple slab, beams, columns, and arcs and shells. So, any shape, pwede mo siyang i-cast. Gawa ka lang ng forma, okay, pag binuhusan mo siya, kung ano yung desired form mo, or may architectural finish ka, ano mo siya, nagagawa mo siya. In most areas, concrete takes advantage of inexpensive local material. So lahat ng material is locally available, okay? Yung sand, gravel, and water. Of course, yung cement natin, meron tayong marami tayong semento. But there are cases na minsan nag-i-import pa rin tayo kasi mas mura yung imported na material compared sa locally manufactured cement natin. Like sa yung project namin dati sa Subic Clark Tarlac Expressway, okay? Yung Japanese concrete, Japanese cement mas mura compared dito. Yung time na kasing yon, masyadong mahal yung sa atin, yung semento sa atin. So nag-import coming from Japan, mas mura pa. So nabawasan yung construction cost ng project. Then number 9, So a lower grade of skilled labor is required for erection as compared to other materials such as structural steel. So ito kahit ano siya, kahit ordinary labor lang siya, yung mga tambay pag pwedeng pwede nang gamitin as laborer. Okay? Ang importante lang kasi sa semento, yung halo niya, yung strength niya. So pag ready mix concrete na yung gagamitin mo, so hindi mo kailangan skilled worker para ibuhos siya, di ba? So ordinary labor lang pwede nang gamitin sa construction. Okay? So ito yung advantage niya, but there are also disadvantages of the concrete. So number one, first disadvantage of concrete, okay? Very low tensile strength, okay? So napakaliit. So in average, ang strength lang ng concrete niya, tensile strength niya is 0.5 square root of F prime C. So makita nyo, less than 10% of the compressive strength yung tensile strength niya. That's why we are sa design, although may strength siya, so additional factor of safety na lang, ni-neglect natin yung tensile strength ng concrete. Second, so forms are required to hold the concrete in place until it hardens sufficiently. So in addition, so yung formworks natin dito masyadong massive. Kaya sa reinforced concrete building, normally yung cost ng formworks is 30% of the construction cost. So ganun kalaki yung requirements sa formwork o yung cost ng formworks sa reinforced concrete structure. Kaya may mga construction company na pag ang ginamit nila yung mga steel forms, mas nakakamura sila kasi pwede mong gamitin yung steel forms na kahit 100 times as long na smooth pa rin yung forma mo, pwede pa siyang gamitin. Kaya nga compared dati sa sa mga construction, pag nagbibid yung mga foreign sa local contractor natin, laging talo yung local contractor natin. Kasi yung ginagamit nilang form is just ordinary plywood o special plywood, yung phenolic board. Kaya lang compared to steel, yung phenolic board, you can use only up to maximum siguro 3 to 4 times. Okay? Pero yung steel formworks o aluminum formworks, more than, perpetual siya hanggat hindi siya nasisira. So, more than 100 times na usage. Okay? Kaya yung time na yon, naging competitive na yung mga local contractors natin nung ginamit na nila yung mga steel forms. Okay. So number 3, so the low strength per unit weight of concrete leads to heavy members. So mas mabigat yung structure natin using concrete. Okay. Then number 4, so the low strength per unit volume. So the concrete means the members will be relatively large. So since napalit yung yung strength niya, o tensile strength niya, lumalaki yung mga size natin ng mga member. So kaya ito yung mga nagiging problema natin sa pag may mga requirements sa architectural. Okay? Kaya another way para lumiit yung size ng concrete natin is ginagamitan natin ng pre-stress o may mga tendons tayo. So nagalagay tayo ng mga high strength tendons para lumiit yung size natin. Pre-stress natin yung member. Then number 5 disadvantage, okay? The properties of concrete vary widely. So kahit hinalo mo siya ng hinalo. So at any distance, walang magkaparehong properties ng concrete. So depende sa pagbuhos mo. Hindi mo pwedeng sabihin na although tama yung proportion mo sa design mix mo, pero yung properties niya at every section nagbabari kasi siyempre hindi mo lang pwedeng i-arrange yung bato mo o yung buhangin mo na pare-parehas yung volume niya per unit volume. Then the last disadvantage is vulnerable to shrinkage and creep. So pwede siyang mag-shrink, diba? Pag habang natutuyo siya, makita nyo may mga nakita kayong micro-cracking. So dahil siya nag-ano siya, dahil lumiliit o nagsishrink yung member, concrete members. Okay? So these are the compatibility of concrete and steel. So concrete and steel work together magnificently in reinforced concrete structure. So the advantage of each material seem to compensate for the disadvantage of the other. So as I've said before, the lack of tensile strength of concrete, okay, so pinupunuan siya ni steel reinforcing bars. And then yung protection naman para kay steel reinforcing bars, ginagawa ni concrete para hindi siya mag-corrode. So the great shortcoming of concrete is its lack of tensile strength, but tensile strength is one of the great advantages of steel. So the two materials bond together very well, so there is no slippage between the two. So they will act together as a unit. So parang nagiging nagiging homogeneous na siya kasi yung bonding niya between concrete and steel is perfect. So the excellent bond obtained is due to chemical addition between the two materials. So the natural roughness of pores and the closest space rib of the rib deformation of the rebar surfaces. So reinforcing bars are subject to corrosion, but the concrete surrounding them provides them with excellent protection. The strength of exposed steel subject to temperature reached in fire of ordinary intensity is practically zero, but the enclosure of reinforcement in concrete produces very satisfactory fire rating. So, siyempre di ba yung concrete natin, pag in-expose mo siya sa fire, there will be a cracking. So that cracking, okay, will arrest by the steel reinforcement. So concrete and steel work together, okay, in relation to temperature change because the coefficient of thermal expansion are quite close to each other. So halos parehas yung thermal expansion niya, coefficient of thermal expansion niya. Kaya pag nag-apply ka ng heat, pag humaba yung concrete mo, hahaba din yung steel or reinforcing steel mo. So hindi siya nag-iiwanan in terms of expansion, thermal expansion. Okay? So mechanical properties of reinforced concrete. So number one, okay, properties for the reinforced concrete is the compressive strength. So the ultimate compressive strength of concrete is determined by the testing of the sample at 28-day-old. Okay? So normally, halimbawa, kung sabi mong 4,000 PSI, okay? So yung test niya lagi is at 28 days. But of course, pwede mong i-design yung concrete mo na early strength. Like yung mga ginagawang repair sa EDSA. So 3-day strength concrete lang yung ginagamit mo. Misa pa nga, 2 days lang. Okay? Kaya lang, maraming konkreto ang kailangan mo doon. Saka yung water-cement ratio, napakaliit. Okay? So yung ginagamit nating testing for compressive strength is yung universal testing machine. Okay, using cylinder. So 150 mm diameter by 300 mm yung length niya. Okay. So normally, yung concrete natin sa Pilipinas ranges from 3,000 PSI for small construction, mga bahay-bahay, okay, to maximum of 7,000 PSI of 50 megapascal. Pero ngayon meron ng mga buildings like sa BGC and Makati na they're using 10,000 PSI. Okay? But in other countries, hanggang 20,000 PSI kaya na nila. Kasi mas maganda yung mga equipment nila compared sa atin. Okay? Sa atin kasi, although mga foreign din yung mga supplier ng concrete natin, pero hindi pa sila capable of doing 20,000 PSI or 130 megapascal concrete. Okay. So, ang standard na ginagamit natin dito for high-rise building is around 5,000 PSI. Okay. But for mga pre-stress, okay? So ginagamitan natin siya ng mga 6,000 to 7,000 PSI or 34 to 41 megapascal. So in designing the reinforced concrete, number one na kailangan mong properties is the compressive strength. So ito yung mga typical stress strain diagram. Okay? So makita niyo siya, ito yung strain niya, ito yung stress. So for 1,000 PSI, ito yung graph niya. Okay? So makita ninyo, habang tumataas yung FRMC niya o 28-day strength ng concrete, mas maliit yung strain niya. Okay? So yung failure niya, kasi nagiging malutong siya habang tumataas yung strength niya. Then another properties na kailangan in designing is the modulus of resistive concrete. So the modulus of resistive concrete, okay, EC, is taken as 4,700 square root of FRMC for normal weight concrete. Okay. For lightweight concrete, so yung mga lightweight concrete kasi, gumagamit tayo minsan ng mga lightweight materials, mga aggregates o mga buhangin, okay, na magagaang. Okay. So normally, yung weight niya o yung concrete weight niya is 1,500 to 2,500 kg per cubic meter. So the permitted, okay, Is of C is dependent on the strength of the concrete. Then Poisson's ratio, although this Poisson's ratio ay hindi masyadong ginagamit sa design, but in analysis, okay, kailangan nating input to. But in determining for the size and the reinforcing bars, we don't need to, hindi natin ginagamit itong Poisson's ratio. Okay. Number 5, tensile strength. Although, disregard natin yung tensile strength, but the tensile strength ranges from 10% to 15% of the compressive strength. Kaya makita ninyo, kahit unreinforced yung beam natin, meron pa rin siyang flexural capacity o moment capacity kasi meron din 10% to 15% tensile strength yung concrete. Okay, shear strength. Okay, of course, the shear strength also function of FRMC. So pag dumating tayo sa design ng mga web reinforcement, so gagamit natin yung shear strength capacity ng concrete. Okay, for the reinforcing bars, so ang available sa atin na reinforcing bars ranges from 6 to 36 mm. Okay, ito yung readily available sa market. But meron tayong available na 51 mm. So yung 51 mm, ito ginagamit na namin sa mga bridges. Okay, lalo sa mga foundation. So ang purpose kasi ng paggamit ng bigger diameter is to avoid the crowding of reinforcing bars, lalo na sa mga beams. So the grade of steel, so we have in the Philippines we have 3 grades. So the 33 KSI or 230 megapascal, the grade 40 or 40 KSI, and the grade 60 or 14 megapascal. So yung available sa small hardware is only 33 megapascal. So for 40 and 60 KSI or grade 40 and grade 60, you need special order. So kailangan i-order mo siya in advance, okay? Unlike sa 33, kadalasan kasi yung 33 KSI o grade 33, ginagamit siya as mga slab on grade, shear reinforcement. Kasi hindi man masyadong critical yung pag mga residential building, hindi critical yung shear requirements sa mga beams kasi napakaliit ng loading. Saka masyadong maiksi yung spanning ng mga beams natin for residential construction. So in some countries, meron silang grade 75 o grade 515 o 517 megapascal. So sa atin, bihira pa lang yung gumagamit ng grade 75. So meron lang ginamit na grade 75 kung nadadang kayo sa Mega Mall, yung may building na tabi ng Mega Mall, nakalimutan ko yung pangalan. Yun yung unang ginamitan ng grade 75 noong 1990, I think 1996. So ginamit yung grade 75 na steel dito sa Pilipinas. Pero ngayon, sa mga bridges na ginagawa na namin, ginagamitan namin siya ng grade 75 para ma-lessen yung quantity ng rebar to avoid congestion. Kaya lang, it takes 2 months, 1 to 2 months, okay, ang order period ng grade 75 kasi imported siya. But compared to grade 60 and grade 75, kung makita ninyo, from 60 to 75, meron ka ng increase, okay? Meron ka ng increase na 25%. 25% increase sa strength. So ibig sabihin, yung yung area requirement mo sa rebar, mababawasan siya ng 20%. Pero yung cost difference ng grade 60 sa grade 75, napakaliit lang. I think parang 1 peso and 50 centavo, less than 2 peso yung difference niya. Kaya kung gagamit kayo ng grade 75, magkakaroon kayo ng savings sa mga 10%, 10 to 15% sa cost ng reinforcing bars. Kaya lang, yung disadvantage lang yung order. So pwede mo siyang i-order in advance. Kaya lang, pag nagkamali ka ng order, may hinto yung construction mo. So nakadepende dun sa sa quantity surveyor mo kung talagang tamang-tama yung yung pag-quantify niya o yung pag-bar bending niya. So wala kang magiging problem sa sa supply as long na naka-advance order siya. Okay, then next is aggregates. Okay. So may mga requirements tayo sa aggregates. Okay, so from NSCP, meron tayong mga requirement kung ano yung mga size ng aggregates. So yung size ng aggregates, okay, will dictate the clear spacing between reinforcing bars. Kasi pag masyado malaki yung aggregates mo, tapos masinsin yung reinforcing bars mo, meron kang clear spacing between bars 20 mm. So 3/4, di ba? Tapos gagamit ka ng 3/4 na aggregates. So titignan mo, para sa 3/4. Kaya lang, due to corrugation, saka due to placement of rebar, hindi mo masasakto yun na na 3/4 yung spacing niya. Pwedeng 3/4, pwede less than 3/4, pwede more than 3/4. So, if you're using 3/4 aggregates o 3/4 na gravel, tapos 3/4 yung o 20 mm yung spacing mo, clear spacing mo, there is a big possibility na magkakaroon ka ng honeycomb. So, hindi papasok yung hollow mo dun sa members mo dahil sa maling usage ng aggregate. So, kaya isa-isa sa mga factor din. Although sa design, hindi natin i-specify. Okay, hindi natin i-specify kung anong size ng aggregate ang gagamitin. But, ito dapat ang titignan ng mga site engineers. Okay? Bago mag-order ng konkreto, dapat checkin muna nila yung members, yung spacing ng bakal, kung kayang pumasok ng mga aggregates. Okay. Next is the load. So, of course, before you come up with the design, so kailangan mo na malaman kung ano ba yung mga loads to be carried by your structure or member. So we have three classification or group of loads. So number one is the dead load, live load, and environmental load. So these dead loads, okay, are those constant in magnitude. So ito yung mga fixed loading na kinikerry ng structure natin. Ano ba yung mga fixed loading? Okay, so number one is yung self-weight niya. Fixed load yun. Second is yung mga utilities. Kunyari, meron ka slab, nakahang yung mga pipes mo o nakahang yung mga fire protection mo or mga lights mo, mga chandelier, mga ceiling. Okay? Yan yung mga dead loads. Yan yung mga loads na lagi siyang in place, lagi siyang nandun. So in computing for the dead loads, yung factor natin in ultimate design, the factor for dead load is 1.2. Meaning, meron tayong 20% allowance o factor for dead load. So ano pa yung mga dead load natin? Yung mga plastering, ceiling, yung tiles natin. Tapos kung meron kang swimming pool sa taas, of course, yung water, okay, as part yun ng dead load. Yung mga waterproofing. So basta lahat ng permanent na nakabit sa structure are considered dead loads. Then yung live loads naman, so live loads consist chiefly of the occupancy load in the building. So ito yung mga tao, okay, for building, yung mga depends sa occupancy. Yung dead load natin, bawa school building, iba yung live load mo. Pag residential, iba rin yung live load mo. Pag commercial building, iba rin yung live load mo. So same true with the bridges. So meron tayong tinatawag na live load. So yung live load natin sa bridges, yan yung mga pedestrian, yung mga dumadaan na pedestrian. Plus, the major live load for bridge is the traffic load. So yung traffic load na yan yung mga weight ng mga kotse, cars, mga trucks. So lahat ng moving load sa bridge, yan yung mga live load. So for live load, so yung factor natin for live load is dati kasi yung factor natin is 1.7 nung old code ng NSCP. Mga NSCP, I think, anong edition yun? Parang 1990 edition ng NSCP. 1.7 yung factor natin for live load. But now, the latest edition, okay, ang factor lang natin for live load is 40% or 1.4. Then, other loads is the environmental loads. So, the environmental loads consist mainly of wind pressure. Okay? So, wind pressure during typhoon. Siyempre, yung wind natin, di ba, either suction siya or pressure. Then, earthquake loads, soil pressure, possible ponding of rainwater. Okay? So, ito yung mga meron kasi tayong mga roof deck minsan na nagkakaroon ng ponding ng water, ng rainwater. Pero masyadong maliit lang yun. But sometimes, kailangan mo rin i-consider. Okay? Lalo na pag nag-deflect kasi yung mga slab natin. So minsan, di ba nakakita kayo sa mga tulay minsan? Nakakita na kayo ng tulay o flyover na merong base ibabaw. So ibig sabihin, nag-deflect na doon yung mga beams o hindi maganda yung drainage system niya. So nagkakaroon ng ponding ng rainwater. So dapat i-consider din niyo yun. Okay? Although maliit lang siya, but at least kailangan mo siya i-consider, lalo especially on the flat surfaces. And another environmental load is yung temperature difference. So sa atin ngayon, yung temperature natin, okay, ranges from, sa Baguio, walang problema kasi yung temperature doon minsan 8 degrees to 20 degrees. Napakaliit no, 12 degrees lang. Pero sa Metro Manila, nakakaranas tayo ngayon ng maximum of 61 degrees yung ano niya, yung tawag doon, yung init nung ano nung temperature. So from 61 to minsan meron tayong 20 degrees, di ba, sa Metro Manila. 20, 22 degrees pag December, pero pag summer 61 degrees. So napakalaki nung difference o change in temperature. So di ba pag sa mga solid, pag nag-apply ka ng temperature, what will happen? So for solid, if you apply temperature, magkakaroon ng expansion. So kailangan natin consider 'yon, yung temperature changes, lalo ah, sa mga buildings na exposed sa high temperature. Okay? Okay, ito yung single reinforce. So on next meeting, we'll be discussing singly reinforced rectangular beam. So hopefully we can finish the working stress design, yung 3 topics na yon in one meeting lang. So after meeting ng WSD, bigyan ko na kayo ng quiz. Basta laging ganon. Basta tatapos natin yung isang topic o 2 topics o 3 topics. Halimbawa, sa next meeting natapos natin yung 2 topic ng WSD. So yun lang coverage ng exam ninyo, 2 topic. Pero pag natapos natin yung 3 topics ng WSD, 3 topics yung exam. Pero pipili lang ako ng 2 item sa 3 topics na yun. Hindi lahat bibigay. Okay, so for the meantime, so yan muna yung initial lecture natin for the reinforced concrete. So just give you an overview lang sa reinforced concrete para maano yung mga component. Tapos meron yata akong meron akong pina-post kanina ng mga video, mga link. So magandang yun, panoorin ninyo para at least magkaroon kayo ng idea sa design of reinforced concrete components. So ano yung mga materials. So from time to time, magpapapost din ako ng mga other videos pa. Okay? Lalo sa mga construction. Okay? Kasi mostly naman bibihira yung yung napupunta talaga sa design. Minsan less than 10% lang napupunta sa design. Mas maraming napupunta sa construction. Okay? So next meeting, wala pang quiz. Kasi pa lang yan, parang introduction pa lang ng reinforced concrete design. Okay? Meron bang questions or clarifications?
Sir, hello po.
Yes.
Sir, okay lang po makihingi ng copy po ng presentation po.
Yes, i-upload ko siya dun sa Google Classroom natin para meron kayong references.
Sir, excuse me po, hindi pa po kasali sa Google Classroom, sir. Wala po akong natanggap na email from you, sir.
Pero nakalista ka dun sa tawag doon sa SIS.
Yes po, sir.
Kaya. Sige, yung mga hindi nakatanggap nung email invites from Google Classroom, i-send nyo na lang sa Messenger o kaya kung sino yung class president ninyo, ibigay sa kanya tapos i-send niya sa akin sa Messenger para may-add ko. Para sa pag-submit ng mga exam ninyo or mga sheet work, meron kayong paglalagyan. Okay?
Okay po, sir.
Yung recording, hindi ko na-record pero next time, i-record ko siya para bigay ko sa inyo yung recording ng natin lecture natin. I think pwede yata i-record dito kasi yung dati, yung isang account ko para hindi pwedeng i-record pero dito yata ngayon pwede siyang i-record. Tapos pwedeng pakisabi niyo dun sa ano, yung mga hindi pa nag-accept ng invitation. Parang ano yata kayo, 130 plus yung ano na student for 3 sections. So paki-inform lang sa kanila baka hindi pa nakikita yung email o baka hindi wala silang email invites. So pakibigay na sa akin yung mga ano, yung mga student na hindi pa na-invite dun sa Google Classroom.
Hello po.
Yes.
Ano po sir, ano pong mga literature po kaya pwede namin gawing reference po para po sa subject na to?
Okay. So sa references, bigyan ko kayo ng ano, i-upload ko sa Google Classroom yung mga list ng references. Although meron akong references ng mga reinforced concrete, kaya lang ang problem is naka-English system siya, walang metric system. So, ang pinamagandang reference na ano na for reinforced concrete na mas madali sa intindihin, yung book ni Engineer Cañete. So, kung makakabili kayo noon, mas maganda yun na reference niyo compared to other books kasi mas simplified yung ginawa niya saka mas madaling intindihin. Saka pa siya, naka-Philippine settings pa. Unlike sa ano, yung sa mga foreign reinforced concrete design book, masyadong mahaba yung ano nila, yung mga discussion na minsan hindi naman kailangan. Okay? So I suggest na bumili kayo ng book ni Engineer Cañete.
Okay po. Salamat po.
Okay.
Tapos po sir, share ko na lang rin po kasi yung iba ko pong kaklase na walang na-receive na invite. Nakita po nila yung invite sa spam po nila sa email. Baka nandun po
Okay. Oo, kasi dinigrade ko yung yung Google Classroom. Yung old Google Classroom kasi dati, limited yung limited yung participants. So in-upgrade ko siya. So binura ko lahat yung dating na invitation tapos nagpadala ko ng bagong invites. Baka hindi na nakita na sa spam nga. Paki-inform lang sila.
Salamat po.
Okay. Tapos pwede nyo i-share sa kanila, halimbawa wala sa invitation, pwede nyo i-share sa kanila yung Google Classroom code natin, tapos i-accept ko na lang sila. Pwede rin isang option yon.
Yung code po, saan po namin makikita po?
Yung code, ibuksan ko lang yung Google Classroom. Ito. Meron kayo makita dun sa sa left part, left portion, meron doon class code. So mag-login lang sila sa Google Classroom tapos ilagay nila tong join class tapos ilagay nila yung code na to. Nakikita ninyo? Oh, yan pwede yung pwede yung i-share sa kanila yan pag wala silang invitations.
Okay na po, sir, na-note na po.
Okay. So meron pang questions or clarifications? Okay, so wala ng question. For the meantime, yan muna yung introduction natin. Then next meeting, yung lecture natin will start mas maaga natin kasi medyo mahaba yung para matackle natin yung at least yung target natin, yung 3 topics sa WSD matapos natin. Okay? I think from 6 to 9 kaya natin tapusin yun. So mag-start tayo next meeting exactly 6 o'clock. So i-open ko na yung Google Classroom by 5:30 para makapasok kayo agad. Okay?
Noted po, sir.
Okay, so wala na questions. Thank you everyone and good night.
Thank you po, sir.
Thank you po, sir.
Thank you po.
Thank you po.
Thank you po.